Hello, and welcome to another edition of the Daily Bolt with your host, Dr. Jeff Tilley. Today's topic, continuation of yesterday's topic on scientific consensus. How valuable is it? Perhaps not as much as you might think. Sit back and relax and enjoy today's Daily Bolt. So yesterday we talked a little bit about scientific consensus not always being the best science. And in fact, I gave a short laundry list of examples of things that were considered to be robust science by a scientific consensus which were disproven, and our understanding was improved dramatically by one or a small number of scientists that were willing to challenge the common view. We have a couple more of those examples that I want to just briefly mention. Maybe we'll just briefly mention. Okay, there we go. So, first of all, with respect to electrical current and Edison's theories, we did talk about those a little bit yesterday. So there's only about 3 of them left on this list to consider, and one is a big one. Basically an idea from the time of the ancient Greeks of a substance called the ether. The ether was this substance which was postulated and believed to exist from the time of the ancient Greeks all the way into the late 19th century. That's a lot of centuries. That was necessary for light to travel. It was nothing that we would consider now as being a reasonable scientific theory, because we know that light has both a particle and a wave nature to how it travels, and that it certainly can travel in a vacuum. This was not accepted as a scientific principle. There was a large scientific consensus all the way from the time of the ancient Greeks until Michelson and Morley in the late 19th century, with their experiments, were able to postulate the nature of light and electromagnetism. Again, this kind of combination of a particle and a waveform, to put it very, very simply, which can travel without any matter present. So it means it can travel in a vacuum, which is how we can basically see light from distant stars. But that was not the accepted consensus for well over 20 centuries, and it was wrong. 2 more recent examples, very recent and very apropos, especially as COVID-19's Delta variant rears its ugly head and potentially causes a lot more restrictions to come back. First, about a year ago, maybe 15 months ago, when there was first talk about trying to develop an effective vaccine for COVID-19, there was a consensus among the medical community that, like any other vaccine for things like the flu, things like the mumps, measles, polio, it would take years, if not decades, to develop an effective vaccine. We still have no vaccine for the HIV virus. And we've been working on that for several decades. So the medical establishment believed that an effective vaccine was not going to be possible to be developed quickly. And that was proven wrong, obviously. I've been vaccinated, half the country's been vaccinated. And another consensus, this one was relatively short-lived by comparison, a few months, to some of the other ones we've talked about, as has the vaccine one. But COVID-19 was believed to be this virus that, we'll shut down travel early in 2020 for a while. We'll have a few restrictions for a couple of weeks, and that'll be all we need to get over COVID-19. It'll be just like the flu, and it won't be a significant problem long term. 17 months later, almost, and we're still dealing with it. And it looks like we're going to be dealing with it for some time to come. So scientific consensus can be something that lasts for a short period of time. It can last for very long periods of time, over 20 centuries, and it's not always correct. So this is kind of the key to what I'm talking about. There's been a lot of talk about, well, you have to follow the science. Is that following really the science, or is it following the scientific consensus? They are not the same, because the scientific consensus, as I have demonstrated both in the examples today and the examples yesterday, can be quite wrong. And doing science by consensus is dangerous, because if you assume that the consensus is always right and the best science, we might not even be here if that assumption had been really followed. Science is always about questioning. It's always about challenging what the accepted beliefs are. So if anything, good science is anti-consensus. And so talking about a consensus of scientists agree on something doesn't necessarily mean that that's right, or even something that you should base policy on. You can go to even more specific examples. In weather prediction, there are a variety of models, and 20 years ago or so, and I was involved in doing some of this work, there was the exploration of doing what we call ensemble forecasting. You either change a little bit about the conditions, the information that goes into the model, or you change some of the physics that you represent and some of the physics that you choose not to represent. And one of the things that it was believed, and this for the most part is true, it does span the realm of possibilities to the point where you can actually give a probabilistic forecast based on the ensemble, and we're gradually starting to do that more and more as time goes on. It did not happen originally with the ensemble system. Often the mean or the average of the ensemble was taken as kind of a consensus. And what was found in some of those early experiments with ensemble modeling is that sometimes the entire ensemble was wrong. And there were some very high-profile forecasts of strong storms, both on the West Coast and on the East Coast, that ensemble modeling systems predicted were going to occur, and they never happened. Because every member that went into this consensus type of a forecast was wrong. And so our science is only as good as the data that we use to put into it, and by the processes that we use to examine the data and perform experiments to test hypotheses. If we abandon that approach in favor of having a consensus reach decisions, especially when many of the scientists in that so-called consensus really have very little direct expertise in the nuts and bolts, the details of that science, in my view, that is dangerous. It is dangerous to base policy decisions on it. It is dangerous to make political statements on it. We really need to get back to science the way it has worked best. Yes, there may be consensus, but challenges to that consensus should not only be accepted, but robustly supported, and not ridiculed, and not canceled. Hopefully I've given you some food for thought regarding science consensus on issues including but not limited to climate change, COVID-19, other ecological and environmental issues. Hopefully you'll think about a little bit about what I've said these past two podcasts. But for now, I'm going to close out this Daily Bolt and this short series. I'm Dr. Jeff Tilling. I hope you have a great night, morning, or afternoon, and have a great rest of your week.